The brain begins to eat itself. This is not a line from a horror movie. It is the terrifying, newly discovered opening chapter of Alzheimer's disease, a chapter that's been hidden from us until now. And it does not begin with a forgotten name or a misplaced key, the moments we all dread. It begins with the silent, insidious theft of a single cent. For decades, we have viewed Alzheimer's as a disease of memory, a cruel fading of the self, centered in the highest regions of our brain, like the lights of a great city blinking out one by one. But what if that's the final act, not the beginning? What if the first battlefield is drawn years, even decades earlier, in a primal, ancient part of our mind we barely think about? A groundbreaking new study has finally pinpointed what could be the disease's ground zero, and it's located, astonishingly, in the brain's smell center. Today, we dive deep into an astonishing story of biological betrayal, a civil war fought on a microscopic scale within our own heads. How do the brain's most loyal protectors, its own dedicated immune cells, turn into ruthless destroyers, devouring our own neural wiring? We will witness the incredible experiments that caught these cellular assassins in the act, revealing their methods and their motive. And most importantly, we will explore the revolutionary and hopeful possibility that a simple, non-invasive smell test could one day become our most powerful weapon against Alzheimer's, a smoke detector for a fire in the mind, warning us of the approaching storm long before the mind begins to unravel. What you are about to hear could change everything you thought you knew about this devastating disease. The story starts not with amyloid plaques, the infamous, sticky villains of the Alzheimer's narrative, but with the unsung heroes of our brain, the microglia. Imagine these cells as the brain's elite special forces, its security guards, and its sanitation crew all rolled into one. They are constantly, restlessly on patrol, extending and retracting delicate feelers, sampling their surroundings, clearing out debris from cellular activity, fighting off infections, and meticulously pruning away dead or dying connections to keep the neural network running at peak efficiency. They are essential for a healthy brain. Without them, our minds would quickly become cluttered with toxic waste. But in the earliest stages of Alzheimer's, something goes terribly wrong. These guardians turn into traitors. A switch is flipped, and their protective instinct becomes a destructive obsession. They begin to target and systematically eliminate healthy, functioning nerve fibers. Scientists at the German Center for Neurodegenerative Diseases, driven to find the very first whisper of the disease, embarked on a painstaking investigation. They turned to a special breed of mice, genetically engineered to develop Alzheimer's-like symptoms. These weren't just any mice. They carried 3 specific human genetic mutations that caused their brains to become flooded with the toxic amyloid beta protein, perfectly mimicking the slow creeping process seen in people. The researchers watched these brains with unprecedented detail, starting from the tender age of just 1 month, looking for the first domino to fall in the long, tragic cascade of neurodegeneration. And they found it. But it was nowhere near the areas we associate with Alzheimer's. It was not in the hippocampus, the sacred library of our memories. It was not in the prefrontal cortex, the boardroom where our highest thoughts are conceived. No, the first assault was happening exclusively in the olfactory bulb, the brain's smell processing center. To be even more precise, the microglia were targeting a very specific set of nerve fibers, those that originate from a tiny, deep brain region called the locus coeruleus. Though small, this cluster of cells is a titan of influence. It is the brain's primary source of norepinephrine, a critical chemical messenger, a neurotransmitter that acts like the brain's volume knob, controlling attention, arousal, and our response to stress. These fibers act as a critical supply line to the smell center, keeping it sharp and responsive, and the microglia were methodically cutting them. The destruction was precise, targeted, and alarmingly early. At just 2 months of age, the equivalent of early adulthood for these mice, they had already lost a staggering 14% of these vital nerve fibers in their olfactory bulb. This was happening months before the first infamous amyloid plaques even began to appear. The damage was relentless and progressive. By 3 months, the loss increased to 27%. By 6 months, a full one-third of these connections, one-third of this critical communication highway, were gone. Meanwhile, other parts of the brain, including those other fiber types like the cholinergic and serotonergic systems, remained completely untouched. This was not random decay. It was a targeted assassination. Using advanced imaging techniques, the scientists watched in astonishment as microglia physically wrapped their cellular bodies around these nerve fibers and literally engulfed them, consuming living nerve connections in an act of cellular cannibalism. So the critical question became, why? Why were these highly intelligent immune cells suddenly attacking their own system with such prejudice? The investigation revealed a molecular smoking gun, a deadly signal of mistaken identity. The targeted nerve fibers were decorated with a specific molecule called phosphatidylserine. Under normal circumstances, this molecule is kept securely hidden on the inside of a cell's membrane. When it flips to the outside, it acts as a universal eat-me signal, a biological white flag of surrender that tells microglia this cell is damaged or dying. It is time for it to be removed for the good of the whole. But these nerve cells were not dying. They were, in fact, hyperactive. The researchers made a crucial discovery. The nerve cells in the locus coeruleus of these mice were firing electrical impulses far more frequently than normal. This state of constant, frantic overactivity, likely triggered by the earliest soluble forms of amyloid beta, was causing the phosphatidylserine to flip to the outside, essentially making healthy, functioning fibers scream for their own destruction. It's a truly chilling discovery, the brain's own hyperactivity, driven by the disease process, tricking its own immune system into dismantling it piece by piece. If you find this insight into the secret and sometimes terrifying workings of our own minds as fascinating as we do, take a moment to hit that like button to let us know. This discovery immediately raised a new, profoundly hopeful question. If we could understand the signal, could we perhaps block it? Could we disarm the assassins? The researchers embarked on a brilliant follow-up experiment. They identified a protein called TSPO, which microglia use as a key part of the machinery for this devouring process, known as phagocytosis. They then used genetic engineering to breed their Alzheimer's model mice with another line of mice that completely lacked the TSPO protein. The results were nothing short of stunning. In the mice without TSPO, the microglia were effectively neutered. They could still patrol, they could still perform their other duties, but they could no longer carry out their destructive mission in the olfactory bulb. The norepinephrine nerve fibers remained intact. The vital supply line was not cut. And most remarkably, these mice performed just as well on smell tests as completely healthy mice. Their sense of smell was fully preserved. This elegant experiment proved that the early loss of smell in this Alzheimer's model was not an inevitable symptom of the disease, but a preventable event driven by a specific and blockable immune pathway. This was a monumental finding in a mouse model, but the ultimate question always remains, does this happen in people? The team turned to the most precious resource in medical research, human brain tissue. They examined samples from individuals who had passed away in the early stages of Alzheimer's disease. They compared them to tissue from healthy, age-matched individuals. The evidence was clear, unequivocal, and consistent with the mouse studies. There was a significant reduction in those very same norepinephrine-producing fibers within the olfactory bulb of the Alzheimer's patients. The human brain was showing the exact same pattern of early, targeted destruction. To take it a step further, the scientists needed to see this process not in the dead, but in the living. They recruited a group of 46 participants, including healthy individuals, those with mild cognitive impairment, a potential precursor to Alzheimer's, and patients already diagnosed with Alzheimer's dementia. They used a specialized brain scan called TSPO PET. This type of scan is like a heat map for brain inflammation. It can detect and measure the activation of immune cells like microglia in the living brain. The scans revealed a striking pattern. The signal for activated immune cells was significantly elevated in the olfactory bulbs of people with mild cognitive impairment. This suggested that the immune assault was at its absolute peak during this very early transitional stage of the disease. Intriguingly, the signal was not significantly higher in those who already had full-blown Alzheimer's, implying that this immune flare-up is an early event that might level off as the disease progresses and spreads like wildfire to other brain regions. This finding is profoundly important. It strongly suggests there is a critical treatment window, a period of time where the damage is localized and the immune system is the primary driver of the pathology. If we could intervene then, if we could calm that microglial fire, we might be able to halt the disease before it ever reaches the brain's memory centers. The results of the smell tests in these living patients sealed the connection. As expected, patients with Alzheimer's scored much lower on smell identification tests than healthy participants. This whole line of research fundamentally reframes our understanding of Alzheimer's disease. It suggests the disease may not begin with plaque, but with an immune system in overdrive, triggered by overactive nerve cells. The attack begins with our most ancient and primal sense, smell, and only later marches on to conquer the regions responsible for our memories, our personality, our very sense of self. The implications are enormous. A simple, inexpensive smell test could become a routine part of a doctor's visit for older adults, acting as an early warning system. Paired with a TSPO PET scan, doctors could potentially identify individuals at the highest risk years before cognitive symptoms become apparent. This early detection is the holy grail of Alzheimer's research, as countless experimental treatments are believed to have failed because they were given too late, after widespread and irreversible damage had already occurred. By catching the disease at ground zero in the olfactory bulb, we open up the possibility of developing entirely new treatments designed not to clear plaques, but to calm the overactive immune system and protect these vital nerve connections. This is not just a story about loss. It is a story of discovery and immense hope. We are finally beginning to read the very first words in the tragic story of Alzheimer's. And with that knowledge comes the power to one day rewrite the ending. These kinds of breakthroughs are happening right now, reshaping the future of medicine and our own health. To stay on the cutting edge of science and understand the discoveries that will define our world, make sure you are subscribed and have notifications turned on. You will not want to miss what we uncover next.